Okay, so we want to do number 19 and 11.7, which says a population of whales declines, sand-based obviously, at 4% per year. The current population is 15,000. Estimate the population in 10 years and figure out when the population will hit 5,000.
So do
Okay.
we start with like 15,000 equals?
Okay, close. What do I start these problems by doing?
Write the model. Skeleton.
Okay, so I should write up the skeleton for a PERT model, which is what?
P of T, P of T, equals P of O, EI.
Okay, cool. I think most of you have this in your head.
And this is the only one I have to have in my head, correct?
Yeah, this is
Not
the only
that
one
other
you.
one?
Yeah, this is the only one you have to have in your head for right now.
Okay.
In later classes, you might learn different models, but this is the one I want to focus on. So this is the one I'm asking about.
So the logarithms and this.
Yeah.
Okay.
So we have our PERT model kind of skeleton, right? Now I should try to fill in some stuff. So what stuff do I know about my model?
Well, I know the current population is 15,000.
The rate of
Sorry.
Okay, so P0 is
15,000.
15,000. What? Wait.
We know our rate.
Oh.
E's a number still. Good. And we know the rate, it's
Negative 4. Oh, negative, that's right.
ah. So I would say it's 0.04, right? But that's going to go up. I want it to go
Down.
down, so it needs to be a negative 0.04.
And then just
And T.
T.
Times.
Okay, so there's my model, populated, done, right? Now what do I do with my model?
Plug in 10 years.
Okay, so I plug 10 years in where? For T? Okay, so I'm looking for P of 10 for this first question. Oops, P of, not T, 10. And that's what?
15,000 negative 0.04 times 10.
Okay. So I get 15,000 e to the
Negative.
negative
Oh,
0.4, right? Multiplying by 10 moves the decimal one place to the
Right?
right.
Oh, shoot.
You're making the number bigger. That should move the decimal point that way. So I got e to the minus 0.4 here. Okay, now what?
Now we want to log it to get that 4 in front?
No?
No, you what? Now take the 5,000. I made 5,000.
No.
Equals. Oh, divided by
get
5,000.
the E
No.
out of there.
Get the E out of there, that's right.
No. There's two questions here, right? One of them is estimate the population in 10 years,
Right?
right? That's plug in 10. This thing's a number. Manipulating it is not going to help you because it's a number.
Oh, so
There's no anything to solve for here. This is just a number.
Oh.
So what does that number represent?
the population.
Yeah, absolutely. That
So-
number represents the population in 10 years, or at least my estimate of it.
We've already found the population. Or do you want us to go farther than that?
Well, so is this a convenient number of years?
Well, we don't understand how many years that is.
Oh wait, years? Is that what this is supposed to be?
Oh, no, we want to know what the population is. but We
No.
still don't know a number of what that population is.
Yeah, this should be a number of whales, right?
Yeah.
Is 15,000 e to the minus 0.4 a convenient number of whales?
We don't know how many whales we have.
Yeah, no, we have no idea how many whales that is. We'd like to know, so what do I do with this thing?
Plug it in.
Yeah, I should plug this into a calculator. What's up?
When you're like over time, I know that like doing it by weeks would be like 10 times better. But if you're doing like years, would you do anything with the number 365 or would it be 12?
So we might consider converting, right?
Yes.
But only if we had a good reason to. So a good reason to convert might be that my rate here is given in 4% per day, and I want to know how many years something's going to take. Or it's 4% per year, and I want to know how many days something's going to take. Right?
So-
Only when my time units are mismatched would I consider converting.
Okay.
Cool?
And then if you did convert, what would you convert it to, the bigger number or the smaller?
Let's get a number here, and then we'll talk about converting.
Okay.
So can somebody give me a number for this? What do you?
.67.
Probably not 200.
Yeah, it doesn't.
Okay. What?
I got
What's
10
.67?
I got 10,000.
E to the negative .4.
Okay, so some of you are getting about 10,000, and
Oh, yeah, afterwards.
and Cole is saying that we get 0.67.
Well, that was for the E to the,
Yeah, and that's exactly this part,
yeah, together.
which is saying that this is about 2/3, right?
Should the.
So we shouldn't be getting 10,000?
No, you should be getting 10,000 for the whole thing. Cole's saying this part is about 2/3.
And do we want to write that up?
You see that?
when
So
we-
when we're putting it in the calculator, we should have, parentheses around the E.
Okay, so putting it in the calculator, we should say, okay, this is gonna be, well, maybe about, right? 15,000, and then we should multiply that number by push the E key, right?
Oh, we gotta multiply by E.
And then that needs a paren and a minus, not the subtract, but the minus key, 0.4. Close a paren.
Okay.
That should give you 10,000.
They gave me
No,
22,000.
we didn't do it right. We quit.
Yeah, oh, yeah.
I did do the
Just
West
take
Coast
one
here.
here.
Okay, so.
Oh,
So-
so you don't even have to put.
Because it's the carrots.
Yeah, you don't have to put multiply.
Yeah, I got the same, because I got the same one.
Yeah, so the TI calculators don't care about multiply, right? They don't care about this symbol being in there. If two numbers are adjacent and are kind of, let's see. So if you put a number adjacent to an E, it will multiply. Cool. So out of this, we get about 10,000.
10,000.
54.
Okay, now I got that, 10,000.
Okay, so what do I answer this first question
Something
with?
is missing in there.
Nothing's missing in here.
So why
We
did you get it right?
say, in 10 years, the estimated population will be
Times, I
approximately
did put that.
10,000.
Exactly. So in 10 years, the population will be about,
About 10,000.
yeah, you really could say about 10,000 here.
Well, can't they do a project to repopulate? Like they're repopulating like the sea otter and the bald eagle population? Like, does that even?
I don't think we need to solve that problem for this.
I'm just asking because I just.
I don't know the biology of this particular species of whale. In fact, I suspect that it might be hypothetical.
So, now they wanna know when it's gonna be 5,000.
Yeah.
If we know that in 10 years it's gonna be 10, can we just say double that?
That's actually a pretty good point. That's an educated guess.
So if we double that time, remember this is multiplicative change. So in 10 years we found it went down by 1/3. So in 10 years we expect that this will also go down by 1/3, which means I'll get to 6,660, whatever. Right? I won't get to 5,000, I'll get to 2/3 of 10,000.
Okay, so then,
So it's going to take a little longer than 20 years and a little shorter than 30.
Could you just say that then?
No, I think we can get a decent number for this. And the way we can get a decent number is we're wondering when does the population hit 5,000, right?
You said equal to 5,000.
So I set 5,000 equal to my model
did tell you that.
Yeah, but you told me in the wrong spot, right?
Oh.
This question is a plug in a years and solve, right? Or simplify. There's no solving here, right? I'm not ever taking an inverse of anything. Here, this guy's going to be a solve.
Big solid effort.
So what do I do from this step going forward?
Divide by 15,000.
Okay, my goal is to get the t by itself, right? So first things first, I'm going to get this 15,000 out of the way.
Why do you get that out first? I'm trying to get
Because I'm trying to get the t by itself, right? So I should get as much stuff as possible away from the t.
Okay. I see.
So what do I get over here? What's 5,000 divided by 15,000?
Ridiculously tiny number. That's still tiny. No.
Oh, each negative .044.
Good.
And then you natural log both sides.
Okay, now I want to get the t down from the exponent, right? So I have a tool for that. That's this natural log thing. Right, why did I pick natural log instead of log base 10?
Because you're using the E number.
Yeah, because there's the e in the base, right? Okay, so I get,
Natural log.
Not Ellen.
log of a third is
Negative .04.
minus 0.04 t. Okay, now to get t by itself, what do I do?
Divided by point zero.
Divide by
Negative.
negative 0.04. You could divide by 0.04 first, but you'll be left with a negative t, right? Then you'll flip the sign at the end. That's also fine. So I'll get here t on the right-hand side. What do I get on the left-hand side?
Approximately 27.46.
Let's forget the approximately for a second. What do I get exactly on the left-hand side?
Natural log over 1/3.
Good. I get a log of a third, right? What I had on the left-hand side. That's just a number, right? And then I divide it by this negative 0.04. So I get that divided by negative 0.04.
Which is 27.46.
Cool. And you guys were having good luck punching that in? Awesome. Cool. So we get t is approximately 27.46. So what do I say?
Approximately 27 years for the population to hit 5,000.
Okay,
Years.
a verb and a subject would be good in that.
Approximately 27 years.
It'll
Whale
take approximately 27.46 years for the pop to reach 5,000.
If it's in years, what would the .46 be?
I'm not doing that.
5,000. Cool? Questions on this?
What would the .46 be? If
Yeah, what's the
27 is
.46? So if we wanted to play converting games, right, this would be a good spot for it.
Yeah.
If I want to know how many days is .46, right, like I'd like to write this as 27 years and
Something.
some days, right, or some months maybe. So I could take my .46, right, that's 46 hundredths of a year,
And just
multiply by 365 and find out that this number is, so 27.46 years is 27 years, and then what do you get when you multiply .46 by 365?
167.9.
167.9.
Point nine? Wow.
Dave?
Times .46 times 365.
Yeah, so it's probably not going to come out quite right. So then I could convert the .9 to hours, That's also not gonna
and
come
then
out
we could ask
conveniently.
it.
And then we could continue this. But remember, this thing's an estimate anyway, right? So playing this game is probably a touch ridiculous. You guys see that? This is a good game to play in some places, but not in this one.
When you're entering that lien 1/3 divided by that, how do you put that in the calculator?
Okay, so to put this in a calculator,
Am
I
doing
need-
the lien and then parentheses 1/3?
okay, I need the natural log, parenthesis, 1 divided by 3, close the parenthesis, divide, and then minus 0.04 will actually work in that calculator. But
Oh,
you
don't do the
need,
negative at the bottom?
you need this minus,
The one at the bottom?
yeah, the one on the bottom right. That's the one that makes things negative. This is the one that subtracts things.
Okay. Now I'm getting it, okay,
Cool?
thank you.
Questions, things?
But what's the difference between making negative and subtracting? I don't even understand why would.
Great point.
Okay.
Your calculator has these two buttons. Okay, the TI calculators have these two buttons. The reason we have, the reason we have these things is, this one just marks something as negative, and this one means do the operation between these two numbers. Your calculator's not good at context. Anything else?